Hello students, this is an exclusive video where we are going to learn midpoint theorem, converse of midpoint theorem and few questions based on these two theorems. First of all, what is midpoint theorem? It states that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of it. Let's say in triangle ABC, midpoint of side AB is D and that of AC is E. According to the theorem, the line segment joining DE, these midpoints, is parallel to the third side of the triangle BC and also half of it. This means that we are given with AD equals to BD and AE equals to EC, and we need to prove that DE is parallel to BC and DE is half of BC. Here we need to construct a ray CX which is parallel to AB and extend the line segment DE to intersect CX at F. So we have two triangles, triangle ADE and triangle CFE, in which angle 1 and angle 2 are equal as they form a pair of alternate angles. AE is equal to EC is given condition, and angle 3 and angle 4 are vertically opposite angles. So we can say that triangles ADE is congruent to triangle CFE by ASA congruent rule. Therefore, DE is equal to EF and AD equals to CF, as they are corresponding parts of congruent triangles. But it is given that DAD is equal to BD. So from result 2, we can conclude that BD is equals to CF. Also, we had constructed BD parallel to CF. Therefore, making DBCF a parallelogram, as one pair of opposite sides is equal as well as parallel. So another pair of opposite side DF and BC are also parallel, or we can say that DE is parallel to BC. From result 1, we can see from the figure that DE is half of DF, and as opposite sides of parallelogram, DF is equal to BC. Therefore, DE is half of BC. Hence, the midpoint theorem is proved. After learning the midpoint theorem, let us take few questions based on this. The question says, in the given figure, D, E and F are midpoints of the sides BC, CA and AB respectively. If AB equals to 6.2 cm, then find the length of DE. If DF is 3.8 cm, then find the length of AC. And if the perimeter of triangle ABC is 21 cm, Then find the length of FE. These are the three sub questions. So if we see in the figure, D and E are the midpoints of sides BC and AC of the triangle. So the line segment joining these midpoints by midpoint theorem is parallel to the third side and half of the third side. So we have DE equals to half of AB. Using the values given in the question, we can calculate DE as 3.1 centimeter. In the same way, D and F are midpoints of the sides BC and AB of the triangle, and by using midpoint theorem, we can write DF is half of AC. Again, using the data given in the question and on calculation, we get AC equals to 7.6 centimeter. Now in the third sub question, we are given with perimeter of triangle ABC. Perimeter of triangle means sum of three sides, AB plus BC plus AC. So if we put the values which are known to us, we have the equation 21 equals to AB is 6.2 centimeter, BC value is not known to us, and AC value we got as 7.6 centimeter. So solving this equation, we get BC equals to 7.2 centimeter. Now E and F are again midpoints of two sides of the triangle AC and AB. So again, by using midpoint theorem, we can say EF or FE is half of BC. Since we know the value of BC now, we can calculate FE equals to 3.6 centimeter. Let us take one more question based on midpoint theorem. It says that in the given figure, LMN is a right angle triangle in which angle M is 90 degree. P and Q are midpoints of sides LM and LN respectively. If LM equals to 9 centimeter, MN equals to 12 centimeter and LN equals to 15 centimeter, then find first the perimeter of trapezium MNQP and the second area of trapezium MNQP. We know that trapezium is a quadrilateral in which one pair of opposite side is parallel. So if we are given with P and Q as midpoints of two sides of the triangle that are LM and LN, then by midpoint theorem we can say that PQ is half of the third side MN and also PQ is parallel to the third side MN. Now we are given with MN equals to 12 centimeter, so we can find PQ equals to 6 centimeter. We also got that PQ is parallel to MN. So one pair of opposite side in quadrilateral MNQP is parallel. Therefore we can say that it is a trapezium. So before perimeter of trapezium, P is midpoint of LM and LM is given 9 centimeter, so we can find the value of PM, the length of PM as 4.5 centimeter. And similarly QN, that is half of LN, because Q is the midpoint of side LN and LN side is 15 centimeter, so we get QN as 7.5 centimeter. PM and QN are the two non-parallel sides of the trapezium. Now perimeter of trapezium MNQP is the sum of all the four sides. That is, Mn is 12 centimeter, Qn is 7.5 centimeter, PQ we got as 6 centimeter and PM as 4.5 centimeter, and adding this number we get perimeter as 30 centimeter. Then second sub question, area of trapezium MNQP. The formula to find the area of trapezium is half the sum of parallel sides into height. Here parallel sides are PQ and MN. So sum of 6 plus 12 into height PM, that is 4.5 centimeter, and on calculation we get area as 40.5 centimeter square. One more question based on the midpoint theorem. In the given figure, D, E and F are respectively the midpoints of the sides AB, BC and CA of triangle ABC. Then prove that ADEF is a parallelogram. So we are given with the midpoints of three sides of the triangle. D as the midpoint of AB, E is the midpoint of BC and F is the midpoint of AC. And we need to prove that ADEF is a parallelogram. We know that parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. So if we take D and E as the midpoints of sides AB and BC, then the line segment DE is parallel to the third side AC by midpoint theorem. Or we can say DE is parallel to AF as A, F and C are on the same line. Similarly, E and F are midpoints of sides BC and AC, so line segment EF is parallel to the third side AB by midpoint theorem. Or we can say EF is parallel to AD because A, D and B are on the same line. So using these two results, we can say that ADEF is a parallelogram because both the pairs of opposite sides are parallel. Hence, we have proved the required result. One more question on midpoint theorem. Again, DEF are respectively the midpoints of sides AB, BC and CA of an equilateral triangle ABC. This time we are given with the triangle as equilateral triangle. We have to prove that DEF is also an equilateral triangle. So we are given with ABC as an equilateral triangle. D is midpoint of side AB, E is midpoint of side BC and F is the midpoint of side AC. We need to prove that DEF is an equilateral triangle. So by using midpoint theorem, if we take D and E as the midpoints of the two sides AB and BC, then the line segment DE is parallel to the third side and half of the third side, that is AC. Same way E and F, if taken as midpoints of BC and AC, then the line segment EF is half of the third side AB. And D and F are the midpoints of sides AB and AC. So we can say the line segment DF is half of the third side BC. Now since ABC is an equilateral triangle, we have AB equals to BC equals to AC. All three sides are equal. So if three sides are equal, then half of each of these three sides are also equal. So half of AB is EF, half of BC is DF, and half of AC is DE. All three are equal. So we can say that DEF is an equilateral triangle. Okay, after learning midpoint theorem and its applications, let us see another theorem which is converse of midpoint theorem. It says that a straight line drawn through midpoint of one side of a triangle parallel to the other side, it will bisect the third side. That means in triangle ABC, if we have D as midpoint of one side AB, through D a line segment parallel to another side BC, it intersects the third side at point E, then E is the midpoint of the third side AC. So we are given with AD is equals to BD and DE parallel to BC, and we need to show that AE is equal to EC, which means E is the midpoint of AC. Like midpoint theorem, same construction is required here also. A ray CX parallel to AB and extend DE to meet CX at F. With this, we have DE parallel to BC as given and BD parallel to CF by our construction. So BCFD is a parallelogram, and therefore its opposite sides CF and BD are equal. But it is given that BD is equal to AD. So with these two equations, we can say that CF is equal to AD. We also have angle 2 equal to angle 1 as a pair of alternate interior angles, and angle 4 equals to angle 3 as a pair of vertically opposite angles. Therefore, the two triangles ADE and CFE are congruent by ASA rule. Therefore, we can say that AE is equal to EC as they are corresponding sides of congruent triangles. Hence, we proved that E is the midpoint of side AC, and thus the theorem converse of midpoint is proved. After learning the converse of midpoint theorem, let us see few questions based on the application of that theorem. The first question says that in the adjoining figure, triangle ABC, AD is the median through A and E is the midpoint of AD, that is median AD. If BE is produced meets AC at F, then prove that AF is 1/3 of AC. So we are given with AD as the median, or we can say D is the midpoint of side BC and E is the midpoint of median AD. We need to prove AF equals to 1/3 of AC. So to use either midpoint or converse of midpoint theorem, we need two parallel lines apart from the midpoints. and we need to prove AF as 1/3 of AC. So let us take a point in between F and C so as to divide AC in the three parts which we will prove equal, and we'll take the point such that it makes a line parallel to BF. So our construction is a line segment DG parallel to BF. Now if we see the triangle ADG, it is given that E is the midpoint of one of the sides AD and EF is parallel to another side DG. So by converse midpoint theorem, we can say that F is the midpoint of the third side, that is AG. Now if F is midpoint, that means we can write AF equals to FG. Let's say this as result 1. Now if we look at the triangle BCF, it is given that D is midpoint of one of the sides in this triangle, that is BC, and we have constructed DG as parallel to another side of this triangle, that is BF. So again by converse midpoint theorem, we can write G as midpoint of the third side, that is FC. Or if G is midpoint, we can say FG equals to GC. Let's say this as equation 2. Now if we see equation 1 and equation 2, equation 1 says AF equals to FG and equation 2 says FG equals to GC. So we can combine these two equations and write AF equals to FG equals to GC. That means the side AC is divided into three equal parts, and hence we can say each part, here we take AF is 1/3 of AC. Another question says that in the figure ABCD is a parallelogram. E is the midpoint of side CD, and through D a line is drawn parallel to EB to meet CD produced at G and intersecting AB at F. We are required to prove two things. First is AD equals to half of GC, and second is DG is twice EB. So we are given that ABCD is a parallelogram, E is the midpoint of side CD, and EB is parallel to DG. We need to prove these two things. So if we say the triangle DCG, E is midpoint of one of the sides of this triangle, that is CD, and EB is parallel to another side of this triangle, DG. So by converse midpoint theorem, we can say that B is the midpoint of third side, that is CG. Or we can say that BC is half of GC. Now we know that in parallelogram opposite sides are equal. So instead of BC, we can write AD as half of GC, which is our first required proof. Now as we have seen in the triangle that B is midpoint of CG and E is the midpoint of side CD, which is given, we can use midpoint theorem and say that EB is half of DG. Or if we cross multiply these two on left hand side, we get our second required proof. Hence, this question is proved. Another question says that in the figure, triangle ABC is right angled at B and P is midpoint of AC, that is hypotenuse. We have to show that P is equidistant from all the three vertices of this right angled triangle. That means we have to prove PA equals to PB equals to PC. So we are given with a right angled triangle as B equals to 90 degree and P is midpoint of AC, and we need to prove PA equals to PB equals to PC. Now to use midpoint theorem or converse midpoint theorem, we need either midpoint or parallel line segments. So we construct a line from the midpoint P parallel to side BC. So we construct PQ parallel to BC and then join PB, because we need to prove that line segment as equal to PA as well as PC. Now since P is midpoint of one line segment AC, that means we can say PA and PC are equal. Let's say this as result 1. Now in triangle ABC, P is midpoint of one of the sides AC and PQ is parallel to another side BC. So by converse of midpoint theorem, we can say that Q is midpoint of AB, or we can say AQ equals to BQ. Now in triangle APQ and BPQ, AQ equals to BQ as we have just proved. Then angle AQP equals to angle BQP, each is 90 degree because PQ and BC are parallel. Angle B is 90 degree. So as a pair of corresponding angle, angle Q is also 90 degree. And we have QP as a common side between these two triangles. So yes, by congruency SAS rule, triangle APQ is congruent to triangle BPQ. So the corresponding sides PA and PB of congruent triangles are equal. Let's say this as result 2, and from result 1 and 2 we see that PA is equal to PC and PA is also equal to PB. So we can conclude that PA equals to PB equals to PC. Hence it is proved. Here we notice that in a right angled triangle, in any right angled triangle, the midpoint of hypotenuse is always at an equal distance from all the three vertices. One more question. It says that in the adjoining figure ABCD is a kite in which AB and AD are equal sides and CB equals to CD is another pair of equal sides. If E, F and G are respectively the midpoints of AB, AD and CD, then prove that first angle EFG is 90 degree, and in second one more condition is given that if GH is parallel to FE, then prove that H bisects CB. So we are given with a kite ABCD where AB equals to AD and CB equals to CD, and E is midpoint of AB, F is midpoint of AD and G is midpoint of CD. We need to prove these two things. So in triangle ABD, we are given with two midpoints E and F of sides AB and AD. So by midpoint theorem, we can say that EF is parallel to BD, and EF is also half of BD, but that is not required here, so we are not writing it. Let's say this as equation 1. Now in triangle ADC, again two midpoints F and G of sides AD and DC are given. So by midpoint theorem, again we can say FG is parallel to AC and FG is half of AC. Let's say this as result 2. Now it is a property of the quadrilateral kite that its diagonals intersect each other at 90 degree, and one of the diagonal bisects the other diagonal, but we need only one property, that the diagonals are perpendicular to each other. So if AC is perpendicular to BD, AC is parallel to FG in result 2, and BD is parallel to EF in result 1. If we combine these three results 1, 2 and 3, we can conclude that EF is perpendicular to FG, or in other words we can say angle EFG is 90 degree. So our first part is proved. Now it is given that EF is parallel to GH. So if we look in the triangle BDC, G is midpoint of one side CD which is given, GH is parallel to BD, we can conclude from result 1 and the given condition of second sub question. So midpoint of one side of the triangle, the line segment is parallel to another side of the triangle. So by converse of midpoint theorem, we can say H is the midpoint of the third side BC, or in other words H bisects BC. Hence we proved both the required conditions. Now let us summarize both of the theorem. In midpoint theorem, given information will be midpoints of two sides of a triangle, whereas in case of converse midpoint theorem, midpoint of one side and that line segment parallel to another side of a triangle will be given in the question. In case of midpoint theorem, we conclude that the line segment joining the given midpoints is parallel to the third side and half of the third side of the triangle. And in case of converse midpoint theorem, the point at which the given line segment meets the third side of the triangle will be the midpoint of the third side. I hope you all have enjoyed this learning. Thank you for joining this session.